welcome back to the tutorial class. So for this tutorial class, I have invited both groups together to attend so that we can one-shot discuss everything together. So if we successfully completed everything, then the Friday group class you don't have to attend also for the Friday class. Okay, so right now I have created a poll to see how many questions you have completed. Can you please do it now so that I can know? Okay, try to vote. Okay, so far there are 12 of you already voted, and some of you still haven't cast any vote for the second poll. So I believe maybe you still haven't started doing it. So we will try to complete the question, then we will discuss the answer by 1:30 p.m. later. Okay. Okay, as I seen there are about 17 students in the classroom right now, but only 13 of you have chosen whether you have complete or not. Can I ask the remaining student to also choose your option? There are 13 of there are 13 vote, but in the classroom there are about 17 students. Where are the remaining 4 students? Okay, just a quick survey. Can you choose uh, if you have completed all the questions for the latest vote, latest poll? Okay, I think half of you have done the question. So maybe we start to discuss our answer first, shall we? So 21, the remaining 9 students already missing. It's okay, no problem. Okay, so let's see the first question. Determine the de Broglie wavelength for the hydrogen atom with a kinetic energy of 1.2 eV. Okay, then the mass for the hydrogen is 1.67 times 10 to the power negative 27 kg. Okay, this one is in SI unit. Okay, so let's see how we're going to do with this question. So at first, we are given the kinetic energy, which is half mv squared. But this one is in the EV form, 1.2 times E multiplied 2 divided by M, which is 1.67 times 10 to the power negative 27, square root, you get a V. Okay, to find the de Broglie wavelength, P equals to H over lambda, lambda equals to H over P. Then your H is a constant, and then your MV, M is given, V is calculated. So you use your lambda to calculate the answer. Okay, what's your answer? Anyone can tell me? So Yin Chang? So Yin Chang, are you here, So Yin Chang? Hey, Mr. So Yin Chang, are you here? Okay, looks like Mr. So Yin Chang is missing. Long Yao Ting, what about you? What do you get for the first question, Long Yao Ting? The answer for the first question, what do you get? Lambda. You will give it back. Okay, 2.61 times 10 to the power negative 11. Okay, which is in the meter. Same answer as me. Okay. So, any question for this? No, right? Okay. For the second question, two semiconductor with the same material properties, except material A has a band gap energy of 0.9 eV, then material B has a band gap energy of 1.10 eV. Okay. Determine ratio of Ni of the material B to the material A for T equals to 200K, 400K, 300K, and 400K. So from the question, we can know that both are having the same material properties, which means that the NC and V will be exactly the same. Okay, so we do this first, and then square for the B. We know that S over 300 to the power 3 exponential negative 1.10 EV multiplied by KT 0.62 times 10 to the power negative 5. Sorry, you don't have to do this. You can do it in this way, 0.0259 multiplied by S over 300. And A do the same. Okay, just that right now your exponential will be equals to negative 0.9, 0.0259 multiplied by S over 300. Okay, then find the ratio. Wong Ga Seng, what do you get for the A, B, and C? Wong Ga Seng, are you here? Okay, give me the answer for the A, B, and C. Okay, 9.2 times 10 to the power negative 6. Second one, okay, 4.3, fair enough. Third one, you should get 3.0503 lah, because of the rounding issue. Okay, and let's see the third one. Silicon at T equal to 300K is stored with the arsenic atoms, such as the concentration of the electron is NO equals to 7 times 10 to the power 15. Find the EC minus EV, determine the EF minus EV, calculate the PO. Which carrier is the minority carrier concentration? Okay, let's see how to do this. So at first you calculate the NO. NO is given 7 times 10 to the power 15. EC minus EF, he wants you to find this. Okay, we know that NO will be equal to the NC exponential minus EC minus EF over KT. In this case, this is a 300K, so we can put 0.0259. Okay, NC is given 2.8 times 10 to the power 19. Then you rearrange it to get the NC minus NF minus EF. Okay, this is the first part. Second part, you will get the EF minus EV. How to find this? In the question, it's given that EG is equals to 1/12. So you just need to use 1/12 minus EC minus EF. Then you get your EF minus EV. Third part, okay, find the PO. PO will be equals to the MV exponential minus EF minus EV 0.0259. So after that, you just need to compare NO and PO, which one is bigger, which one is smaller, to determine that which carrier is the minority carrier. Okay, so let me pick some guy to answer this. So Yan Chan, are you still here? Okay, looks like he's missing in action already. Chan Xupian, are you here? Chan Xupian? Okay, can you tell me the answer for this all this question? A, B, C, D. Okay. 0.2148, yeah, correct. 0.9052. Next one. What about your PO? Okay. The next one. Minority. Yep. Whole carrier concentration. And then calculate the EF minus EFI. Okay, this one is a little bit tricky. It's okay, 0.3 about that. Okay, nothing much. Okay, number 4. Consider the silicon at T equals greater than K with the donor concentration of ND 10 14, 15, 16, and 17. Assume NA is equal to 0, and I 1.5 times 10 to the power 10, and Z is this one. Calculate the position of the Fermi energy level with the respective to the conduction band energy for this donor concentration. Okay, you are given the ND. Based on the ND, you can find the NO. Based on this formula, NO equals to the ND minus NA divided by 2 plus ND minus NA divided by 2 square plus NI square. Okay, so after this one NO, you can use back the original formula, which will be equal to the NC exponential minus EC minus EF over KT, where the NC will be equal to the constant 2 times 10 to the power negative 19. Okay, 19, not negative 19. Okay, and then determine the Fermi energy level with respect to the intrinsic Fermi energy level. Okay, in order for you to do this, you can also write in this way. NO equals to the NI exponential. You can refer back to the lecture 4, this formula, EF minus EFI. EF minus EFI over KT. Okay, so let me pick some guy to answer this. Kwai Yihang, are you here, Kwai Yihang? Can you tell me the answer for the, let's say, 10 to the power of 14 for both answer for both A and B, for the 10 to the power 14 A and B? Okay, 0.3249, 0.228. Okay, good. Next one. Yong Ming Liang, are you here? What about the next one? Yong Ming Liang. Using wrong formula, okay. Chia Chai Siu. What about you? Can you tell me the answer? Okay, let's check. What about B? Yep, correct. Next one, Hu Hing Dong. Are you here, Hu Hing Dong? Then what about 10 to the power 16? Okay, 0.2056. Next one. Zero point 3473. Yep, correct. Okay. 70 I skip first. Okay, because it's a repeatable one. Okay, let's see. The Fermi energy level at silicon 300 K is 0.22 above the intrinsic Fermi energy level at 9. Then determine the NO and the PO. Repeat for the NA. GA, repeat for the gallium arsenide. NI equals to 1.8 times 10 to the power 6. So basically, this one you just use these two formula. Okay, either use this and use this to calculate the NO and PO only. Okay, EF minus EFI is 0.22. Okay, then you just need to dump in the value to calculate the answer. So let me check. Okay, Lou Tong-Ye, are you here? Lou Tong-Ye, what's the answer? For A and B, and no and the PO. Okay, 7/3 times 10 to the power 13, 3.06 times 10 to the power 6. What about B? Okay, 8.8 times 10 to the power 9 and 368. Okay, the next one. The concentration of the donor impurity is Nd equal to 10 to the power 15. Assume the mobility mu n 1300 and the mobility of a hole 450, complete the resistivity and the conductivity. So we have experienced quite a lot of time for this question. So since this one it didn't give you the Na, so we assume that Na will be equal to the 0. And also this was a silicon, the Ni will be equal to 1.5 times 10 to the power 10. Okay, so basically we have to use this formula. Everything we do, NO will be equal to ND minus NA divided by 2 plus ND minus NA divided by 2 square plus NI square. And then we use the NI square divided by the NO to get a PO. And then mu NN plus mu PP. This will be equal to the conductivity. Resistivity will be equal to 1 over conductivity. Okay, so let's see who can answer me. Lu Jiaming, are you here? Okay. It's okay. Easy, are you here? What's the answer for the conductivity and the resistivity for the question number 6? Okay, haven't complete. Ng Han Xiang, are you here? What's the answer for this question? What do you get? For the conductivity and resistivity. Okay, 4.8 or 4.9 rounding problem. Up 0.28. Wait, is that correct? So let me check. Maybe I type one more. 1 divided by 4.90. Okay, my bad. Okay, this one should be 0, not 10. Typo. Okay, fair enough. Number 7. Gallium arsenide silicon semiconductor resistor is stored with the donor impurities of ND equals to this. Cross sectional 5 times 10 to the power 5, current 25 MA with the applied bias of a 5V, 5 watt. Determine the length of the resistor. Assume the mobility mu n is this, mu p is this, and now is 1.8 times 10 to the power 10. So in order for you to do this, you can refer back to the lecture 6 regarding the resistor part. Okay, based on this part, we have dealt with it a lot of time. Okay, let's put it side by side. Okay, from the question, we can know that we are given some info. I 25 MA, then V equals to 5V, V equals to IR, no problem. And then we can also equals to this. V divided by I will be equals to the R, L, A. Okay, so he asked you to find the L. Okay, so cross sectional is A. This one is 5 times 10 to the power -5. This one, conductivity. Mu nm plus mu pp. We do the same thing. We assume that Na will be equal to 0. Okay, so mu n is given, mu p given. Calculate the n, calculate the p, then substitute inside. So based on this 3 and 4, you can calculate the L. Okay, let me pick someone to answer this question. Lim Chun Wei, are you here? What's the answer for this question? The length of the resistor. Zero point 0.3103. Oh, I guess 0.0272. Okay. What about the remaining students? What do you get? Do you get my answer or Lim Chung Wei answer? Okay. All right. 0.0272. Okay, Lim Chung Wei, you better check the answer again. Okay, question number 8. Calculate the VBI in the silicon at T equals 300 for the Na equals to 2 times 10 to the 15 and Nd equals to 2 times 10 to the 15. Okay, we all know that this will be 0.0259 multiplied by ln Na and D over Ni squared. Ni squared you can get from the list. I don't want to repeat again. So we can have a 3 different answer, 2 times 10 to the 15, 2 times 10 to the 16, 2 times 10 to the 17. Okay, let me pick someone to answer this. Brenda, are you here, Brenda? Okay, can you tell me the answer for these 3? 0.6113 volt. Second one, 0.6711. Yep, correct. 0.3731. Yep, correct. Okay, question number 9. Assume a doping concentration at T by 300K and D 10 to the power 17 and N 10 to the power 14 for the zero bias. Calculate the VBI, SN, SP, Emax. Then mu is the 1.03. It already given you, so you don't have to calculate everything again. So this one we repeat many times already. You can use the formula for the lecture 8 or lecture 7 if I'm mistaken. Okay, let me open my lecture 7. Formula is given there, no problem. You don't have to half file it, you just need to use it only. So basically this one, using this mu s is given, so you can calculate easily. And then let me see. Go back to the question. He also asked you to calculate the VBI. So let me choose some of you to answer this question. On mailing. Are you here on mailing? Okay, can you answer me the first three, A, B, and C? A, B, C, D lah, all together. 0.635, yeah. Next one. Okay, 2.865. 2.865. Next one. Okay. 0.635, 2.865, and 10 10 to the 4, 4425. Yeah, correct. Wait, give me one moment. Okay, the last one. NA equals to 2 times 10 to the 17 and D equals to 4 times 10 to the 14. Determine the VBI, same thing. Cross-sectional area and the reverse bias is this one, 2.5. Calculate the VBI, SN, SB, W, and E max. Okay, so basically this one, we all just repeat the same thing only. Okay, this is a silicon. So we know that what answer to be used, what kind of answer to be used. Okay, so okay. At first, T equal to 300K. What is the answer? Let me choose someone. Ernest, are you here, Ernest? Ernest? Okay, can you tell me the answer for the last question? Okay, 8081. So basically, it's 8081. I don't think you need to do anything. SNSP. Okay. M. Yep. Next one. Okay. W and E max not yet done. Okay, who can tell me the last two? Okay, let me see who will be the last lucky one. Chua Yu Yang. Can you tell me the last two answer? Okay, about that. Yeah, the last one. 184 times 10 to the power 3. Okay, I used the mu, so that's why the answer will be slightly different, but no worries, still okay. Okay, so I think basically that's all for today. Any question? Okay, question number 4. Let me open back again. Ah, yeah, close it down already. Tutorial. Okay, position of the terminology with respect to the conduction band, which means it's a EF minus EC. So you are supposed to have a negative value in front of that. Okay, EF minus EC. Understand, Benda? Okay. So I think that's all for today. Thank you very much. So I will see you during the final online assessment. So for those who are supposed to have a Friday class for the tutorial class, you don't have to come anymore. Okay, since we discussed everything already here. Okay, so I think that's all for today. Thank you very much for the attention. Have a nice day. Have your lunch now. Okay, bye everyone.